We like to think of history as a straight road, beginning with the first faint traces of early humans, passing through the civilizations of the Nile, Mesopotamia, India, and China, and finally arriving at the glittering cities of today. But that is only the thin surface of a book billions of years long. When we flip back the earlier pages, we see dinosaurs ruling for hundreds of millions of years. And if we turn even further, we fall into a gap stretching across billions of years, pages erased, where no one can say for certain what truly happened. In that dark interval, entire worlds without names may have risen and vanished, intelligent beings who left behind no monuments or machines, perhaps only whispers lost in stone. Maybe they once breathed this same air, looked up at the same blue sky, and then disappeared as if they had never existed. Is intelligence a privilege unique to us, or is it a melody the earth has played many times before, each refrain erased by the machinery of time? This is not science fiction. It is a journey into deep time, into the hidden heartbeat of the planet, where a terrifying question lingers. Are we only the latest version in a long line of civilizations that flared and were forgotten? This is Deformed History. If you're drawn to stories like these, the ones that live in the shadows between what we see and what was made to disappear, feel free to like and subscribe only if it feels right, and let me know in the comments, where are you watching from, and what time is it for you right now? I love seeing our little map of watchers light up around the world. Imagine standing on the edge of a canyon at sunrise, watching the first light reveal layers of stone stacked one upon another, each band a different shade of red, ochre, or gray. Geologists call this a stratigraphic record, a kind of natural archive, because every layer was once a world in itself. An ancient floodplain, a seabed, a desert, a forest. When you look closely, you realize you are staring at millions of years compressed into walls of rock. Now, stretch your mind further. Picture not just a canyon wall, but the entire Earth, its crust reshaped again and again, continents splitting apart, colliding, vanishing beneath oceans. Every page of that immense book has been written, erased, rewritten, and much of the early story has been lost. This is what scientists call deep time, a scale so vast the human brain can barely hold it. If Earth's 5 billion year history were compressed into a single calendar year, modern humans would not arrive until the very last minute before midnight on December 31st. Dinosaurs would dominate from about December 13th to December 26th. That leaves 11 months unaccounted for, 11 months where entire possibilities could have unfolded. The temptation is to dismiss the idea that anything resembling civilization could have existed in those forgotten months. We tell ourselves the arc is simple. Single-celled microbes, then plants, then dinosaurs, then mammals, then us. But nature has never followed simple scripts. Life surges, collapses, experiments, restarts. The fossil record we rely on is not a complete chronicle, but a patchwork quilt stitched together from rare moments of preservation. Most creatures never fossilize at all. Soft tissue decays, shells dissolve, wood rots, even bones can vanish unless conditions are perfect. Think about that. The vast majority of living beings that ever walked, swam, or flew on this planet left no trace. And if entire ecosystems can vanish without a mark, what chance does a city have, or a machine, or a library of knowledge? Consider how quickly our own creations would fade if humanity disappeared tomorrow. Within decades, glass towers would shatter, Steel bridges would rust, roads would crack under weeds, satellites would fall from orbit within a few thousand years. Even concrete, which feels eternal to us, would crumble in a few tens of thousands of years. Stretch that to millions, then hundreds of millions. What would remain of New York, Beijing, or São Paulo? Almost nothing. Perhaps a faint chemical trace. Perhaps a pocket of unusual metals in a sediment layer. Perhaps not even that. Now imagine another species, unimaginably distant in time, evolving intelligence long before the first dinosaur stirred. They may not have looked like us. They might not have walked upright or spoken with voices. Their intelligence could have been expressed in ways we struggle to imagine, through chemical signals, through patterns in light, through a collective hive mind that functioned as one organism. If such a species built, experimented, altered its environment, how would we recognize its traces? We expect stone monuments, carved symbols, tools of metal, but those are our markers, not universal ones. An earlier civilization might have woven its world from organic materials designed to dissolve back into nature. Its footprint could have vanished almost as soon as it was made, erased not by catastrophe, but by design. Deep time is cruel in its indifference. The ocean floor we stand on today is no older than 200 million years because tectonic plates constantly recycle themselves. Older crust sinks into the mantle, melts, and resurfaces as new rock. Anything built upon those drowned continents is gone, swallowed by the planet itself. The land that holds our homes today may, in a few 100 million years, rest miles beneath another continent, its stories compressed into mineral veins or obliterated entirely. On such scales, even memory becomes geological. Think back to the Permian period, about 250 million years ago, before the rise of dinosaurs. The world then was populated by creatures like Dimetrodon, reptile-like beings with sail-shaped backs. Forests spread across supercontinents. Swamps teemed with life. And then came the Great Dying, the largest mass extinction in Earth's history, when volcanic eruptions and poisoned oceans wiped out more than 90% of marine life and 70% of land species. That apocalypse nearly sterilized the planet. What if, tucked within those vanished forests, something had already rouched awareness? What if it ended, swept away so thoroughly that not a bone or brick remained? The extinction we record in rocks might also be the erasure of intelligence. It feels unsettling because it asks us to loosen our grip on the comforting idea of uniqueness. We want to be the first, the pinnacle, the only. But the Earth is unimaginably old, and intelligence may not be a once-in-eternity event. It may be something that flickers into being when conditions align, like lightning sparking in a storm, only to fade again when those conditions collapse. In that sense, the question is not, did it happen? But, how many times has it happened? And how often have we failed to notice? Standing at the threshold of such mystery, the line between science and imagination blurs. Yet the inquiry itself is deeply scientific. How would we detect evidence of a civilization erased by deep time? We would not expect intact cities. We would search instead for anomalies. Chemical fingerprints in ancient rocks, unusual concentrations of metals, isotope ratios that hint at massive combustion. These are the kinds of signals our own civilization is leaving behind in just a few centuries. Spikes of carbon from burning fossil fuels, strange synthetic compounds, radioactive isotopes from nuclear reactions. millions of years from now, those may be the only echoes of us. And if we can leave such echoes, why couldn't another? As the sun climbs higher over that canyon wall, the shadows shrink and the stone layers glow brighter. Each band is a reminder of a forgotten age, a vanished sea, a forest turned to coal, an ecosystem wiped away. You can trace with your eyes the absences, the gaps, the silences. And in those silences, you can imagine a story that stretches far beyond our own. A story in which intelligence is not a singular flame, but a torch passed and dropped, relit and extinguished, over and over across the vast theater of Earth. The rocks will never tell us directly, but they invite us to wonder. And in that wonder lies the possibility that we are not the beginning of the tale, only the latest line in a chorus older than the continents themselves. If you close your eyes and picture the Earth not as a globe spinning in space, but as a living, restless body, you can begin to sense how fragile memory is on this planet. Mountains rise like breaths and collapse like sighs. Rivers carve valleys, then vanish as new seas flood the land. Whole continents drift apart, collide, and stitch themselves back together. To us, a city feels permanent, a monument eternal, but to the Earth it is little more than a sand castle waiting for the tide. This is why the search for deep history, the kind of history that stretches hundreds of millions of years, is less about finding ruins and more about learning to read the whispers in stone. When you hear the word fossil, you might think of bones locked in rock or the skeleton of a dinosaur displayed under museum lights. But fossils are rare gifts, exceptions rather than rules. For something to fossilize, countless conditions must align. The body must be buried quickly, oxygen must be cut off, the sediments must harden, and the rock must survive tectonic shifts and erosion for millions of years. Most living things never win that lottery. Even the giants of the past, the dinosaurs themselves, are known mostly from fragments, scattered bones, partial skeletons. Entire species came and went without leaving behind so much as a tooth. Imagine then how little chance there is for a tool, a building, or an artifact to endure across the abyss of time. Yet the absence of evidence does not equal evidence of absence. Consider a rainforest today, dense with vines and insects, birds and mammals, a cacophony of life. If that forest were to vanish tomorrow, swallowed by an ocean or subducted beneath a continent, what would survive? Maybe a trace of pollen preserved in ancient sediments, maybe a chemical signature in the soil. The towering trees, the intricate webs of life, the hidden predators and prey, all gone, as if they had never existed. The same holds true for any civilization that may have risen before us. Without fossils or artifacts, the only record might be invisible, written into the chemistry of rocks. This is the premise of what some scientists call the Silurian hypothesis, named with a wink at a science fiction series, but grounded in serious thought. The idea asks, if an industrial civilization had existed millions of years ago, would we be able to detect it today? The unsettling answer is maybe not. Our planet is too efficient at cleaning itself. Wind and rain wear down structures, tectonic plates drag the crust into the mantle, and biological processes consume whatever remains. What endures are not monuments, but patterns, spikes in carbon isotopes, unusual layers of metals, subtle disruptions in sediment that suggest something unnatural took place. Think of our own world. In just a few centuries of industrial activity, we have altered the atmosphere, thinned the ozone, acidified the oceans, and filled sediments with plastics and synthetic compounds. These are not visible ruins, but chemical fingerprints. Millions of years from now, if another species were to sift through the layers of rock we leave behind, they might find these anomalies and wonder what happened. They might not find skyscrapers or airplanes, but they might find a sudden burst of carbon-12, the isotope released when we burn fossil fuels. They might find traces of microplastics preserved in deep sediments, or unnatural isotopes left from nuclear activity. To them, these would not look like artifacts, but like mysteries, signs that something extraordinary happened, then ended. This brings us to a strange kind of humility. We often imagine that if a civilization once flourished before the dinosaurs, we would surely know. We would have found ruins, tools, carvings. But what if we are looking for the wrong things? What if their markers were never meant to last? Or what if we have already stumbled across anomalies, strange mineral deposits, unexplained isotope ratios, unusual fossil patterns, and simply filed them away as natural curiosities? Science trains us to be cautious, to avoid extraordinary claims without extraordinary evidence. But sometimes that caution blinds us to possibilities hiding in plain sight. Let's wander back further, beyond the dinosaurs, into the vast and murky time called the Precambrian, which makes up nearly 90% of Earth's history. This era stretches from the birth of the planet to the sudden explosion of complex life about 541 million years ago. For billions of years, life was microscopic. Bacteria, algae, simple cells forming mats across shallow seas. To most people, that sounds dull, like a blank page in the story of life. But those microbes transformed the planet. Around 2.4 billion years ago, tiny cyanobacteria began pumping oxygen into the atmosphere, triggering what is known as the Great Oxidation Event. Oxygen, which sustains us today, was toxic to many earlier life forms, and the event caused a mass extinction. Imagine it, the air itself becoming poisonous, wiping away entire worlds of creatures invisible to us now. This was no gentle transition. It was a planetary revolution, a biological apocalypse. The lesson here is that Earth has already erased entire eras of dominance. Whole biomes have lived and died, leaving only faint chemical signatures. If microbes could change the atmosphere so drastically that billions of years later we still see the imprint, what might an intelligent species have done, even if it lasted only a short while? A sudden spike in carbon, a layer of fused rock, a pocket of unusual metals could be all that remains of their time on Earth. And we would never know unless we chose to look differently. This is why the forgotten eons matter. Most of us stop at dinosaurs when we think of deep time, as if they are the benchmark of the ancient. But dinosaurs are recent compared to the first 3 billion years of life. Before them stretched vast ages, the Archean, the Proterozoic, the mysterious Ediacaran, names that sound alien because they describe worlds alien to us. These were ages of microbial mats, of strange, soft-bodied creatures that left almost no trace, of continents drifting into shapes we can barely reconstruct. And in those blank stretches, imagination begins to stir. What if intelligence sparked in one of those lost worlds? What if it lived for a few thousand or even a few million years, then vanished under the churn of continents and oceans? Standing on a cliff above the sea, watching waves crash against stone, you can almost feel that erasure in action. Every wave scrapes at the rock, pulling grains away, smoothing jagged edges. Multiply that by millions of years, and even mountains crumble. If civilizations rose and fell in that endless rhythm, their stories would not be carved into stone tablets waiting for us to find. They would be reduced to whispers in the chemistry of the earth, faint anomalies scattered like clues in a puzzle we are only beginning to see. To grasp just how easily civilizations can vanish, you only have to imagine what would happen if humanity disappeared tomorrow. The hum of engines would fall silent, lights would flicker out, and within weeks vines would creep across walls and asphalt. Insects would swarm unchecked, animals would reclaim abandoned neighborhoods, and the first storms would break glass, flood subway tunnels, and peel away the illusion of permanence. Within a century, forests would swallow suburbs, and skyscrapers would stand like brittle skeletons, their steel ribs rusting, their concrete spines fractured by frost. Archaeologists in some future age might find only shards of metal mixed with soil, or layers of plastic fragments compressed into strange new rocks. Fast forward another 1,000,000 years, and even those fragments would be crushed by sediment, scattered by tectonic shifts, or melted back into magma. The digital record we prize, billions of words, images, and voices stored in fragile servers, would vanish within decades. Our most powerful ideas could be lost faster than the walls of our homes, and yet we imagine that if something like us existed before, we would surely see the evidence. But time is not generous with memory. Consider the surface of the Earth itself. Most of the crust, older than 200 million years, has been recycled. The ocean floor, for instance, is astonishingly young compared to the age of the planet. At mid-ocean ridges, new crust forms as molten rock rises. At subduction zones, that crust slides back into the mantle, destroyed and reborn. This conveyor belt of stone erases any history written upon it. Cities built along ancient coasts, the way ours cling to shorelines, would be gone entirely, consumed not by war or disaster, but by the patient machinery of geology. Even on land, where ancient rocks endure, the surface is constantly altered, uplifted into mountains, eroded into valleys, folded, faulted, split. What once stood proud can vanish not in an instant, but in a silence that stretches across eons. This is the quiet violence of deep time, erasure by indifference. To the earth, memory is a burden it does not carry. It recycles itself, turns pages by tearing them out, and leaves us with fragments of chapters that barely hint at the story. We confuse those fragments with the whole. When paleontologists reconstruct a timeline from bones and shells, they are working with less than 1% of what once lived. If 99% of life leaves no fossil, why should we expect 100% of civilizations to leave monuments? Let's return to an ancient chapter often overshadowed by the drama of dinosaurs, the Carboniferous period, about 360 to 300 million years ago. The world then was lush, a greenhouse of swamps and giant trees, the air thick with oxygen. Dragonflies the size of hawks drifted above dense forests. Amphibians crawled along riverbanks, and early reptiles tested the edges of new worlds. Today, we know this period mainly because its forests, buried and compressed, became the coal beds that powered our industrial age. But imagine if an intelligent species had emerged among those forests. Their traces might have been entombed along with the trees, their cities converted into seams of black rock that miners would later burn without ever suspecting the presence of anything but plants. Coal is, after all, the memory of forests reduced to fuel. Could it also hide the memory of something more? Skeptics will point out that we have no clear artifacts, no tools or carvings, and that is true. But absence of evidence is a fragile shield against possibility. Think of the Ediacaran creatures, soft-bodied beings that lived more than 570 million years ago. For decades, their fossils puzzled scientists because they looked like nothing alive today. Some resembled discs, others fronds, some had quilted patterns like mattresses. They lacked mouths, limbs, or bones. For a long time, they were ignored or dismissed because they didn't fit neatly into our tree of life. Only later did we realize they were real, a lost experiment of evolution, life forms that thrived for millions of years and then vanished without descendants. If we could overlook entire ecosystems for decades because they didn't make sense, how much easier would it be to overlook signs of intelligence that don't match our expectations? The problem is that we think of civilization in human terms, cities, writing, tools of stone or metal. But intelligence is not confined to our blueprint. Termites engineer complex mounds with natural air conditioning. Beavers reshape rivers with dams. Octopuses solve puzzles and use coconut shells as armor. Crows bend twigs into hooks. These are not human inventions, yet they are inventions nonetheless. Scale them forward across millions of years and ask yourself, could another lineage have crossed the threshold from clever survival to deliberate shaping of the world? And if they did, would their mark be obvious, or would it blend into the chaos of natural processes? There is a concept in archaeology called preservation bias. The record is skewed toward what survives, not what was most common or most important. We know ancient Egypt not because it was the only great culture, but because it built in stone that resisted time. Entire societies that lived in wood, reed, or clay vanished almost completely. Their stories are whispers, their artifacts rare. Extend this bias back hundreds of millions of years, and it becomes nearly absolute. Only the most unlikely traces could survive. A chemical signature in rock, a peculiar concentration of metals, perhaps a distorted remnant that no longer resembles its origin. We may already have encountered such clues and dismissed them as anomalies. And so, the idea of a pre-dinosaur civilization is less about believing in myths and more about learning to doubt the silence of the past. Silence does not always mean emptiness. Sometimes it means we are deaf to the frequencies still echoing in stone. Perhaps the earth has tried intelligence before. Perhaps the light has flickered more than once. We do not yet know. But when you stand in a canyon, or gaze at a mountain range, or touch the rough face of an ancient rock, you are touching a page from that immense book of time. Most of its words are gone, but a few letters remain, etched in minerals and fossils, waiting for someone to read them differently. Walk along a wind-swept shoreline and watch how the ocean behaves with stone. Waves crash, retreat, crash again, dragging grains of sand, eroding cliffs, reshaping coastlines. What feels solid to us, the granite boulders, the limestone ledges, is already vanishing, chipped into fragments that will one day be nothing more than pebbles, then dust, then sediment pressed into some future layer of rock. The earth does not preserve its memories kindly. It grinds them down, folds them inward, and reuses them. This is why the question of lost civilizations is so haunting. Even if something extraordinary did exist millions of years before us, the planet itself would have conspired against its survival. The Earth is not a museum, it is a restless engine, and its default setting is forgetting. Consider the process of subduction, where one tectonic plate slides beneath another, carrying entire landscapes into the planet's mantle. Mountains, rivers, forests, everything disappears into a zone of crushing heat and pressure. In time, that swallowed crust melts and rises again as volcanic rock, unrecognizable from what it once was. It is as though the planet takes photographs, tears them up, and recycles the pieces into new albums. Most of the ocean floor is less than 200 million years old because of this recycling, despite the Earth itself being over 4.5 billion years old. If we built a civilization today on the seafloor, it would be erased in a geological instant. Cities, industries, even entire nations would be drawn into the mantle and obliterated. And yet, there are survivors, fragments of Earth's early skin that never sank. Geologists call them crytons, ancient pieces of crust that have floated stably for billions of years. You can find them in Canada, Australia, South Africa, places where some of the oldest rocks on Earth are exposed. These rocks are relics of the Hadean and Archean eons, eras when the planet was still cooling, when oceans were forming, and the first cells were stirring in tidal pools. But even these survivors are scarred, baked, and transformed by time. They preserve whispers, not speeches. Inside them are chemical traces, ratios of isotopes, rare minerals, that hint at oceans long gone, atmospheres now vanished. They tell us that life may have begun early, perhaps within the first billion years. But they do not tell us everything. They are too few, too damaged, too quiet. This fragility of evidence is what makes the imagination so persistent. Think of the Cambrian explosion, roughly 541 million years ago, when complex life suddenly flourished in a burst of diversity. Eyes evolved, shells hardened, predators and prey invented entirely new strategies. Before that, in the long Precambrian, the world seemed quiet. Yet soft-bodied Ediacaran organisms left impressions in rock that reveal a different reality. They looked like discs, fronds, quilted mats, life forms we can barely categorize. For decades, scientists debated whether they were plants, animals, fungi, or something entirely alien. They had no mouths, no skeletons, no obvious way of reproducing. And then, just as suddenly as they appeared, they vanished. The strangeness of the Ediacaran biota reminds us that life has always experimented. Not every experiment survives, but each leaves a trace if we are lucky enough to find it. Now take that same principle and apply it to intelligence. What if, somewhere in the billions of years before the Cambrian, an evolutionary path gave rise to awareness? Not human awareness, not even animal awareness as we know it, but something else, a network of organisms acting as one, perhaps, or a lineage that communicated chemically, or a species that built with materials that dissolved back into the environment. Such intelligence might have left no monuments, no bones, no obvious artifacts. Its story might be as fleeting as the Ediacaran creatures, erased almost entirely, leaving only a puzzle for future eyes. The silence we interpret as emptiness might actually be evidence of erasure. And yet, not all clues are lost. The Earth keeps certain kinds of records better than others. Chemical signatures, for example, can persist even when bones and buildings cannot. When organisms breathe, eat or decay, they alter the ratios of isotopes in their environment. Carbon, in particular, exists in different forms, carbon-12 and carbon-13, and life prefers the lighter isotope. When massive amounts of carbon-12 appear in the rock record, it can mean something extraordinary happened, a burst of biological activity, a mass extinction, or perhaps even widespread combustion of carbon-based fuels. Scientists studying deep time sometimes find such spikes and wonder what caused them. Volcanic eruptions, methane releases, or something else entirely. This is where humility enters. The data we gather from ancient rocks is sparse and often ambiguous. We explain anomalies with the most conservative answers available because extraordinary claims require extraordinary evidence. But what if, hidden in those anomalies, is the faint echo of something intelligent? What if the strange chemical layers we attribute to volcanoes were partly shaped by hands, or by something we do not recognize as hands? We cannot prove it, but we also cannot dismiss it entirely. The Earth's archive is too incomplete, too heavily edited by time. Picture a forest fire today, a blaze tearing through trees and brush, leaving behind a blackened scar of ash and charcoal. In a few decades, new growth will erase the scar, but beneath the soil, the chemical imprint will remain for centuries. Multiply that by millions of years, and you begin to see how subtle signals can endure even when landscapes transform. If an ancient civilization burned fuel, smelted metal, or altered its environment on a large scale, the echoes might still be buried in stone. Not ruins, not machines, but patterns, shadows of behavior. To find them, we must learn to read the earth not as a record of what survived, but as a palimpsest, a text overwritten countless times, with faint traces of earlier stories still visible between the lines. In this way, every canyon, every cliff, every seam of coal or layer of limestone becomes a question mark. We mine coal to power our world, yet coal itself is the fossilized memory of forests older than dinosaurs. What if, deep within those seams, there are stories we have not recognized? What if our hunger for energy has caused us to burn the very libraries of Earth's past, page by page, without ever knowing what was written there? The unsettling possibility is that the evidence we seek may already be gone, consumed by our own engines, released as smoke into the sky. And so, standing at the edge of an ocean, watching waves devour stone, we begin to see the earth for what it is. Not a vault preserving its treasures, but a crucible where even the strongest memories melt. If intelligence once flickered here before us, it did not vanish because it was small or weak. It vanished because time itself is merciless. The question that lingers is not whether we will find proof, but whether we are willing to accept that the absence of proof doesn't close the case. Sometimes the silence of stone is not a final answer, but an invitation to imagine what might have been. Step into a museum and look at a fossilized ammonite, a spiral shell frozen in stone. It feels like a direct link to a vanished ocean, a creature that swam while continents were still clustered together in strange shapes. But for every ammonite that survived long enough to be fossilized, there were millions that dissolved, crushed, or disappeared. This imbalance is what paleontologists call the tyranny of chance. The record of the past is not a fair sampling. It is a lottery where only the luckiest survive. That is why our confidence in knowing prehistory is more fragile than it seems. We see a few puzzle pieces and imagine the whole picture, but most of the pieces are gone. If that is true for shells and bones, which have hard parts, what chance does a tool have? What chance does a civilization have if it built in wood, fiber, clay, or even organic materials designed to return to the soil? The odds collapse to near zero. This is the hidden problem with artifacts. They are only as eternal as the materials from which they are made. Consider how we build. Our skyscrapers depend on steel and glass, our homes on wood and concrete, our technology on silicon and plastic. Yet each of these is vulnerable. Steel rusts, glass shatters, wood decays, plastic breaks down under sunlight and heat. Even the most advanced microchip, a marvel of human engineering, would not survive more than a few thousand years exposed to the elements. Over hundreds of thousands or millions of years, the Earth would reclaim everything, crumbling it into dust or dragging it beneath shifting plates. Unless conditions were perfect, burial in oxygen-free sediments, preservation in extreme cold or dryness, almost nothing would last. Imagine a city built 500 million years ago, not of metal and stone, but of biotechnological materials, perhaps structures grown like coral reefs, designed to integrate seamlessly with the environment. To its builders, such integration might have been a triumph of wisdom. To us, millions of years later, it would be indistinguishable from natural formations. The ruins would dissolve back into ecosystems, and future species would never know they had been there. Our definition of technology blinds us to other possibilities. We expect machines and engines, but perhaps intelligence can shape worlds in ways that do not leave behind gears or wires. Consider the octopus, an animal with remarkable intelligence, capable of problem-solving, mimicry, and even escape artistry. It has no bones, no skeleton, no permanence. If octopuses went extinct tomorrow, how long would their memory last? In a few million years, no trace would remain, except perhaps a faint chemical marker in the sediments of coastal waters. Yet, in their brief time, they would have demonstrated behaviors we associate with complex cognition. Scale that up across geological time, and you begin to see how intelligence might rise and vanish without fossils or monuments. It may have happened countless times before, and each time the record was erased. When archaeologists excavate human history, they usually find the durable things: stone, pottery, metal. These survive because they resist decay. But early humans also made baskets, clothing, tools of wood, houses of reeds. Almost all of those are gone. Entire cultures have disappeared because their material legacy was fragile. Extend this truth back millions of years, and it becomes overwhelming. We demand proof, yet we do not see how unlikely proof really is. We measure the possibility of lost civilizations against an archive that is already more silence than speech. There are, of course, oddities. Strange spheres found in ancient rock layers, curious grooves in mineral nodules, out-of-place artifacts reported by miners or explorers. Most of these have been explained as natural formations, misidentifications, or hoaxes. But the very fact that such mysteries arise speaks to our hunger for connection, our suspicion that the story is larger than we know. Some anomalies may indeed be geological quirks. Nature is adept at creating shapes that mimic design. Others remain unresolved, lingering in collections and archives, tagged with labels like problematic fossil or unclassified specimen. Science prefers clarity, but sometimes the past refuses to be neat. And then there is time itself, the ultimate adversary of memory. Imagine holding a clay pot in your hands, a vessel 5,000 years old, its surface still etched with patterns made by an ancient hand. It feels like permanence, a triumph of endurance. But 5,000 years is a blink compared to the million-year scale of geology. Even stone erodes, inscriptions fade, structures collapse. Time stretches like an ocean, and our artifacts are boats made of paper, carried briefly before they sink. If we can find only scraps from our own past, how can we expect to find anything from a past that may be hundreds of millions of years removed? And yet it is not hopeless. If artifacts rarely survive, other traces might. Chemical residues, isotopic anomalies, unusual mineral concentrations, these are the signatures we might detect. A spike of carbon in an ancient layer, a sudden change in nitrogen cycles, a cluster of metals that should not be there. These may not be monuments, but they are fingerprints. They are the kinds of signs that our own civilization is leaving behind now. Our factories, engines, and farms are altering the chemistry of the planet in ways that will be detectable long after our buildings are gone. If we can create such a fingerprint in centuries, why could not another civilization have done the same millions of years ago? Picture a coal seam, black and glossy, formed from forests that lived before the dinosaurs. We mine it, burn it, and release its stored carbon into the sky. But within those seams, could there be other secrets, traces of something more than trees? The thought is unsettling. We may already be erasing the evidence, destroying it in our hunger for energy, scattering the last clues of a forgotten age as smoke across the atmosphere. If so, the past might be hiding in plain sight, lost not because it was never there, but because we are too busy burning it to notice. The mystery of artifacts, then, is not simply that we have not found them, it is that we may not recognize them even if we do. A lump of oxidized metal could be dismissed as a natural mineral. A shattered fragment of glass could be mistaken for quartz. A pattern carved into stone might be filed away as erosion. Our assumptions filter our vision. We see what we expect to see. And if intelligence once walked this earth long before us, it may have left behind not cathedrals or statues, but faint, unrecognizable remnants that we overlook every day. Think of the earliest tools we know. Chipped stones, simple flakes struck off a larger core to make a sharp edge. They date back about 3.3 million years, long before modern humans, created by hominins whose names most people have never heard. These artifacts look primitive to us, but they represent a revolution. With a single strike of stone against stone, a creature crossed the line between using what nature provided and reshaping nature for its own purposes. From that moment, the world was never the same. Yet even these tools, so durable in their simplicity, are rare. Most were lost, broken, or ground back into dust. The only reason we have them at all is that they were made of stone and happened to survive in the right conditions. Now imagine pushing the clock back not millions but hundreds of millions of years. What if a different lineage discovered tools long before the first dinosaur walked the earth? Not chipped stone blades, perhaps, but something else, adapted to their own form. A claw sharpened with intention, a piece of shell used to dig, a hardened secretion shaped into a weapon. Would we even recognize those as tools if we found them? Or would they look like random fractures, odd fossils, meaningless shapes? The deeper into time we go, the more our definitions falter. We tend to think of intelligence in human terms: language, art, architecture. But intelligence may reveal itself in subtler ways. Birds use twigs as hooks to extract insects. Sea otters smash shells with rocks balanced on their bellies. Dolphins pass learned behaviors from one generation to the next, a kind of cultural memory. These are not human societies, yet they are societies nonetheless. They show us that the spark of innovation is not unique to us. It flickers across the tree of life, appearing wherever circumstances allow. If that is true today, why should it not have been true 100 million years ago, or 500 million, or even 1 billion? The challenge is that most tools are ephemeral. A stick sharpened to a point rots away in years. A shell used as a cup dissolves. A structure built from mud or woven from reeds vanishes within decades. Only stone persists, and even then, only if it is buried, protected, forgotten, until someone stumbles upon it. But what if an ancient civilization never relied on stone? What if its tools were biological, organic, even symbiotic? Imagine a species that grew its tools the way coral builds reefs or trees sprout branches. Imagine technology designed not for permanence, but for dissolution. From their perspective, that might have been wisdom. Nothing wasted, everything recycled. But for us, millions of years later, it would mean silence. Their legacy would leave no ruins, only whispers in the sediment. And what if their intelligence looked nothing like ours? Perhaps it was not a matter of individuals inventing tools, but of collectives shaping environments together. Think of termite mounds, towering structures with ventilation systems more efficient than many human buildings. They are not planned by architects, they are emergent, built from countless tiny actions, guided by instinct but producing astonishing complexity. Now imagine a species that took that principle further, a society whose very biology drove it to construct, modify, and adapt landscapes. We might not call that civilization in the traditional sense, but it could still represent a form of organized intelligence. The traces would be indistinguishable from natural patterns: layered soil, strange sediment deposits, geometric formations dismissed as quirks of geology. It is unsettling to realize how narrow our search criteria are. We look for pottery shards, carved bones, foundations of stone. But those are the products of our path. Other paths might have left nothing recognizable. A civilization could have flourished in the oceans, manipulating currents, cultivating reefs, engineering ecosystems in ways invisible to us now. It could have lived underground, carving caverns that later collapsed and filled in, leaving only distorted mineral seams. It could have relied on chemistry, shaping life itself, and left its record not in ruins, but in genetic traces buried deep within the tree of life. And even if such clues exist, how would we distinguish them from the endless creativity of evolution? The truth is, we often mistake absence for certainty. We say there was nothing before us because we have not found evidence. But absence is a fragile argument. The fossil record already hides far more than it reveals. Entire forests, whole lineages, vanished ecosystems, all gone without a trace. The Earth is a ruthless editor. It keeps only what is lucky enough to survive, and even that is often incomplete. If tools older than bones once existed, we may never know. And yet, the possibility lingers. Think about how quickly we might vanish. If humanity ended tomorrow, how long would it take before even the oldest stone tools outlasted our satellites? The tools of our ancestors, chipped from rock millions of years ago, may endure longer than our glass towers and digital archives. That irony should give us pause. Permanence belongs not to complexity, but to simplicity. The more advanced our creations, the more fragile they become in the face of deep time. And so we are left with a question that feels less like speculation and more like humility. If tools older than bones were once made, how would we ever know? They may have dissolved into the soil, been transformed into minerals, been mistaken for natural shapes. They may lie beneath oceans now gone, or deep within mountain ranges that have yet to erode. They may even have been found already, resting in drawers of museums, labeled as curiosities, dismissed as unremarkable. We may have held the past in our hands and failed to see it. This is the haunting beauty of deep time. It does not hand us clear answers. It offers fragments, silences, puzzles. It forces us to consider that what we know is only the tiniest sliver of what has been. The earliest tools we celebrate as human achievements are recent scratches on the surface of an unfathomably old world. Beneath them, deeper than bones, deeper than stone, may lie stories we have not yet learned how to read. Technology feels permanent when you hold it in your hand. A smartphone shines with glass and metal, a car roars with power, a skyscraper pierces the sky. But permanence is an illusion. Strip away the people who maintain them, and these wonders collapse faster than we want to believe. Glass fractures, circuits corrode, engines seize, skyscrapers buckle under their own weight. Even concrete, which we imagine as eternal, begins to crumble in just a few thousand years. Now stretch that decay across 1,000,000 years, or 100 million, or 500 million. The machines and monuments that define us would dissolve until nothing recognizable remained. This is the fragility of technology, and it forces us to wonder, if another civilization rose long before us, what would be left of theirs? Consider our own world in the absence of people. Within decades, forests would reclaim cities, vines splitting concrete, roots lifting pavement, trees sprouting through rooftops. In a few centuries, rust would eat through bridges and towers. In a few millennia, glaciers, rivers, and shifting soils would erase even the foundations. Within 1,000,000 years, tectonic activity would bury the ruins beneath layers of rock, or perhaps drag them down into the mantle itself. Even plastics, which we curse as indestructible, would not survive indefinitely. Ultraviolet light breaks them down, microbes consume them, heat melts them. Under the right conditions, a few fragments might fossilize, preserved as thin veins of synthetic polymer in the rock record. But most would vanish. Our libraries, our digital archives, the vast record of our thoughts and achievements would rot away long before any future species could find them. Now imagine a species that mastered technology hundreds of millions of years ago. Perhaps they built not with glass and steel, but with compounds designed to integrate into nature, materials meant to return to the soil without waste. To them, this may have been wisdom, a sustainable triumph. To us, it would look like nothing at all. Their entire legacy could have been composted back into the planet, leaving no trace but the faintest chemical residue. Even if they built with harder substances, time would eventually strip those away. Unless their structures were buried instantly in just the right conditions, their technology would be as lost as ours will one day be. Sometimes we comfort ourselves by saying that if such a civilization had existed, We would have found its tools, its monuments, its machines. But the truth is, we are not very good at recognizing what does not fit. If we stumbled upon an object in ancient rock that no longer resembled its original form, an oxidized lump of metal, a distorted shard of glass, a cluster of fused minerals, would we know what we were looking at? Or would we catalog it as a natural oddity, then move on? Our imagination is often too narrow. We expect artifacts to look like ours, forgetting that intelligence could take different forms and express itself with different technologies. Think about how animals shape their environments today. Beavers dam rivers, changing ecosystems for miles around. Ants cultivate fungus, farming underground in elaborate chambers. Corals build reefs that shelter thousands of species. Each of these is a kind of technology, though it does not involve machines. If one of those lineages had continued evolving for millions of years, what might their technology have become? A reef that grows into geometric shapes, mistaken for mineral formations. A colony that engineers the chemistry of its soil, leaving behind patterns we read as natural anomalies. A lineage that mastered bioengineering long before we even dreamed of it. And what if their technology was not external at all? We assume progress means building machines, but what if progress meant folding the machine inward, integrating it into biology? A species might develop neural networks, chemical communication, or even genetic manipulation so advanced that tools became unnecessary. Their technology would be their bodies, their communities, their ecosystems. Once they vanished, nothing would remain but life itself, and we would never suspect that intelligence once guided it. This possibility is unsettling because it challenges our definition of civilization. We equate civilization with visibility, with monuments, artifacts, ruins. But what if the highest form of advancement is invisibility, a harmony so deep with the environment that nothing unnatural is left behind? By our standards, that leaves no proof. But by theirs, it may have been the greatest achievement to exist, flourish, and disappear without a scar. The irony is that our own civilization, despite its scale, might leave just as little. Future geologists millions of years from now, if they exist, may find nothing of our cities. They may see only a thin line in the rock, a carbon spike, a cluster of strange isotopes, a layer of microplastics. They may debate what caused it. Volcanic eruptions, methane releases, or something else, and they may never be certain. That is the fate of technology in the hands of time. It does not guarantee memory. It guarantees only a temporary extension of power, erased when the clock runs long enough. Picture an abandoned spacecraft orbiting Earth. Within decades, solar radiation degrades its panels, micrometeorites scar its surface. Within centuries, orbital decay pulls it into the atmosphere, where it burns to ash. Nothing remains. Now extend that across millions of years. Even the things we launch into the sky are temporary. Our presence in the universe, impressive to us, is fragile against deep time. Technology does not ensure remembrance. It ensures only function for a while. After that, it is at the mercy of geology, erosion, and chance. So we return to the question. If an ancient intelligence existed, where is its technology? The answer may be simple and humbling. It is gone, eaten by time, erased by stone, buried beneath oceans, recycled into magma. The silence we hear is not proof of absence. It is proof of the Earth's patience. If a civilization rose before us, its technology has already passed through the grinder of deep time, reduced to hints so subtle we may never see them. And perhaps that is the lesson. Technology is not permanence. It is a flare, bright for a moment, then gone. Our mistake is believing the flare can last forever. The Earth has already watched countless flares ignite and fade. Ours is just the latest, and if we vanish, our machines will vanish too. What remains will not be monuments, but whispers, chemical echoes, geological puzzles, faint shadows in stone. Enough perhaps for some future mind to wonder, as we wonder now, were we alone, or just the most recent in a line of civilizations that rose, shone, and fell into silence? When we speak of intelligence, we often picture ourselves as the pinnacle, toolmakers, language users, architects of machines and cities. But intelligence does not belong exclusively to us. It is a thread that appears and reappears across the tapestry of life. Octopuses slip through mazes, unscrewing jars to free themselves. Elephants recognize their reflections and mourn their dead. Crows not only craft tools but plan for tomorrow, hiding food with the strategies that anticipate theft. Dolphins communicate with symbols, pass knowledge between generations, and even call each other by unique names. These sparks remind us that intelligence is not a singular miracle, but a recurring possibility. If it appears in so many places today, how many times might it have appeared in the past, only to be erased by time? The fossil record tells us that life has endured at least 5 mass extinctions, each one wiping the slate clean, reshaping the path of evolution. After the Ordovician extinction, marine species collapsed and new forms emerged. After the Devonian, fish and early amphibians gave way to different lineages. The Permian extinction nearly sterilized the planet, killing more than 90% of life. Then came the Triassic extinction, paving the way for dinosaurs, and finally the Cretaceous, ending their reign and opening the door for mammals. Each time, dominance shifted. Each time, survivors reinvented the world. Each of these great resets could have silenced an experiment in intelligence before it had the chance to spread. Perhaps the record of that intelligence was ground into the dust, along with the species that carried it. We assume that intelligence builds upon itself, that once it appears, it marches upward toward civilization. But that is a projection of our own story. Nature does not climb a ladder. It branches, meanders, restarts. Perhaps awareness bloomed in a reptilian lineage during the Permian, or in an aquatic species during the Devonian, or in a soft-bodied creature of the Cambrian seas. Perhaps they reached a threshold where they began to shape their surroundings, to plan, to imagine. And then came disaster, volcanoes, oceans poisoned, continents breaking apart. Their brief flicker of intelligence was extinguished, leaving no trace except the possibility itself. Even today, the forms of intelligence we see challenge our expectations. A crow shaping a hook from a twig is engaging in abstract thought. A cuttlefish, shifting its skin into waves of color, communicates in ways we barely understand. Ant colonies behave like superorganisms, no single brain in charge, yet producing coordinated behavior that rivals human cities in scale. What if, in some forgotten age, a lineage like this crossed an unseen boundary, transforming cleverness into civilization? Their structures might not have been towers of stone, but vast hives, or reefs, or networks hidden underground. Their records might not have been carved symbols, but chemical signals, songs in frequencies lost to time. or genetic alterations passed down in life itself. To us, those would not look like civilizations. They would look like nature, indistinguishable from the world around them. This raises a deeper, more unsettling thought. Intelligence may not always be a path to permanence. In fact, it may carry its own seeds of destruction. We see this in ourselves. The very tools that make us powerful also place us at risk. Our technology alters the climate, poisons ecosystems, and threatens the balance that sustains us. If another intelligence once walked this earth, they too may have stumbled into that paradox. Perhaps they expanded too far, consumed too much, destabilized the systems around them, and collapsed. Their end might have looked to the rocks like any other extinction: a spike of carbon, a sudden disappearance of species, a silence. We would read it as volcanoes, or methane releases, or asteroid strikes. But perhaps, just perhaps, it was the echo of intelligence ending itself. Standing in a forest today, you hear echoes of that possibility. Bird calls weave into a chorus, insects buzz in endless rhythm, leaves shimmer with wind. It feels eternal, but forests are fragile. A single fire can wipe out acres. A shift in rainfall can transform green into desert. Multiply that fragility across geological time, and entire biomes can rise and vanish without warning. If an intelligent species once lived in such a forest, what would remain? Perhaps nothing more than coal, seams of compressed vegetation where their world once stood. Perhaps we burn those seams today without realizing we are burning the memory of something more than trees. And what if intelligence is not an endpoint, but a cycle? The earth may give rise to it again and again, each time erasing the evidence, each time beginning anew. We are not necessarily the first. We may not be the last. We may only be a chapter in a book that has been written and erased many times before. This view changes the question. It is not, did intelligence exist before us? But how often has intelligence risen and fallen, and what does that say about our future? If others came before and vanished, then perhaps our fate is not guaranteed. Perhaps intelligence is not survival's gift, but survival's gamble, a bright flame that burns too hot and too fast. This perspective is humbling. It strips away the arrogance that says we are unique, the sole spark in the dark. Instead, it suggests that we are part of a pattern, a recurrence, a possibility that keeps trying itself on Earth's stage. Maybe the planet wants to think. Maybe consciousness is its experiment, its way of looking back at itself. And maybe that experiment has succeeded, faltered, and failed more times than we will ever know. So when we look at the silence of deep time, we should not assume emptiness. We should assume hidden stories. Every canyon, every layer of stone, every chemical anomaly in the rock record could be a faint echo of minds that once were. We may never prove it. We may never hold in our hands an artifact that says, unmistakably, "We were here before you." But the possibility itself reshapes how we see ourselves. We are not the beginning of intelligence on this planet. We are simply the intelligence that happens to be here now, walking atop the graves of others who may have asked the same questions, who may have looked at the stars and wondered if they were alone. Look down at the rocks beneath your feet and imagine the stories they could tell if they had voices. Each layer is a page of time, compressed and altered by pressure, heat, and the endless churn of geology. Some pages are blank, some are scribbled with chemical signatures, Some bear the faint impressions of creatures long vanished. We read what we can. The fossils, the isotopes, the strange anomalies that hint at mass extinctions, bursts of carbon, shifts in sediment. But most of the story is gone, erased by the ceaseless motions of continents, the slow grinding of plates, the ebb and flow of oceans. And within those lost chapters, perhaps there are stories of intelligence we have never recognized, civilizations that flourished and disappeared before the first dinosaur even hatched. The deeper you go, the stranger the possibilities become. Consider the metallic spheres discovered in Precambrian rock in South Africa, over 2 billion years old. Their perfect symmetry, grooves spaced evenly, puzzled miners and scientists alike. Most were explained as natural mineral formations, a product of high pressure and chemical reactions. Yet the sense of order, the mathematical regularity, hints at the uncanny. Imagine if such formations were the fingerprints of a civilization that melted, forged, or shaped minerals in ways we can barely comprehend. Would we recognize them as intelligent? Or would we dismiss them as geological quirks? Our expectations are narrow. They filter what we see. Now picture an ocean teeming with soft-bodied creatures hundreds of millions of years ago. They glide, swim, and interact in ways we will never fully reconstruct. Some may have exhibited behaviors that, in the context of their environment, were astonishingly complex. Tool use, manipulation, adaptation on a scale we would label intelligent. Perhaps entire communities coordinated, like the ant colonies of today, shaping currents, engineering habitats, leaving only subtle chemical traces behind. Imagine if their intelligence was slow, patient, organic, integrated into the rhythms of the world. In the stone layers we study now, their presence could be completely invisible. Even the fossil record, fragmentary as it is, occasionally presents enigmas. Some tree trunks remain upright through multiple layers of sediment, surviving floods and shifting geology. Certain rock layers appear vitrified, as if melted and fused, flat and uniform, almost industrial in character. Are these natural events, lightning strikes, volcanic activity, asteroid impacts? Perhaps. But the imagination lingers. Could these be traces of technology lost to time, ancient energy harnessed and applied, then vanished? The Earth holds clues, but they are subtle, easily overlooked, easily misinterpreted. And we often misinterpret them because we seek only what fits our preconceptions. Stone monuments, human-like tools, clear evidence of conscious planning. Consider the chemistry of the Earth itself. Life alters it, even subtly. Carbon ratios shift, isotopes vary, metals concentrate. In our own era, humans are creating a record of change that will outlast buildings, roads, and cities. Fossil fuel combustion leaves a distinct signature. Plastics embed themselves in sediments. Nuclear isotopes persist. Imagine another species producing similar effects millions of years ago. We would not find their factories or their machines. We might only detect anomalies in chemistry, disruptions in sedimentation, traces of metals concentrated in ways nature does not produce alone. This is the kind of evidence that may remain long after form and structure are gone. Think about the concept of tools older than bones. Early humans shaped stone, leaving marks that endured for millions of years. But what if intelligence existed long before bones, before skeletons, before creatures we can even recognize? A claw used to dig, a hardened secretion manipulated with purpose, a shell wielded as a scraper. These would vanish without a trace, leaving only the faintest chemical or textural hints. Intelligence does not have to look like us. It does not require hands, fire, or written language. And if it once existed in forms utterly alien to us, our search for it is handicapped by the narrowness of our expectations. Now think of the Precambrian seas, Ediacaran life forms, creatures that defy classification. Discs, quilted mats, fronds, soft-bodied, symmetrical, puzzling. Scientists debated their identity for decades, often dismissing them because they didn't fit into known categories. These life forms were experiments of evolution, thriving for millions of years and then disappearing. If we can overlook entire classes of life for their unfamiliarity, how easily could we overlook intelligence that left no obvious artifacts, no lasting monuments, no skeletal remains? How many possibilities lie hidden in the chemical and mineral record, overlooked because they do not resemble what we expect intelligence to produce? Every canyon, cliff, and sediment layer is a question. The Earth is not a museum. It is a crucible, grinding down, recycling, altering. Deep time stretches so far that even our longest-lived species are a flicker. Dinosaurs dominated for 165 million years, yet we see them only in fragments. Humans, with just a few 100,000 years of presence, have already begun leaving chemical fingerprints that may endure. The contrast between presence and permanence is stark. Intelligence may rise, innovate, flourish, and vanish without a trace. The deeper the eons, the more ephemeral the record. So when we peer into deep time, what do we find? Silence, blank pages, occasional anomalies that hint at something extraordinary, patterns that defy casual explanation. It is tempting to fill these blanks with imagination, to envision civilizations lost, intelligence extinguished, worlds engineered and forgotten. And perhaps that is what we must do. Imagine responsibly, using the fragments as guides, recognizing that absence of proof is not proof of absence, and that the Earth's memory is patient but selective. In that space between stone and silence, between chemistry and imagination, lies the possibility that intelligence has walked here before us, shaped the world in ways we can barely perceive, and then vanished into the abyss of deep time. Picture a forest long ago, swaying in a warm breeze, the sun filtering through leaves taller than a man. Birds call, insects hum, the air is thick with oxygen and the smell of damp earth. Beneath the surface, roots tangle with fungi, mosses coat rocks, streams carve channels into soft soil. This forest existed hundreds of millions of years before humans ever walked. It thrived, it died, it vanished. Its memory lives in coal seams, faint chemical residues, and sediment layers, but the richness of life, the web of interactions, the intelligence embedded in survival strategies, is gone. Now imagine another intelligence operating in that same forest. Perhaps it navigated the rivers, shaped the land, experimented with early forms of construction or organization. Not for show, not for permanence, but as an extension of its awareness. If they vanished, time would reclaim them as efficiently as it reclaimed the forest. The lesson is that permanence is rare. Mountains erode, rivers change course, oceans rise and fall. Even continents drift across the globe, colliding, tearing apart, reshaping the crust. The land beneath us has rarely been stable over hundreds of millions of years. If a civilization arose on a continent that has since sunk beneath the ocean, its legacy would be buried under kilometers of water, compressed, transformed, melted into new rock. Even on land, tectonic forces bend, fold, and fracture the crust, destroying the fine details of what once existed. A city built in the Triassic could be utterly unrecognizable today. Its foundations dragged deep into the earth or broken into fragments we would dismiss as natural anomalies. And yet, traces can survive in the subtlest forms. Chemistry, isotopes, concentrations of elements that do not occur naturally. These are the fingerprints left behind when time erases the obvious. Imagine a layer of sediment where carbon ratios shift abruptly, hinting at massive combustion or altered ecosystems. Perhaps metals appear in unusual clusters, or organic polymers are preserved by chance in oxygen-deprived mud. These are the hints scientists look for, the ghostly shadows of activity long past. They are not monuments, not machines, not structures, but whispers that something extraordinary happened, then vanished. The earth is patient, but indifferent. It does not favor intelligence. It erases, recycles, repurposes. Entire ecosystems, species, lineages have been lost without leaving more than faint chemical footprints. Dinosaurs, the giants that dominate our imagination, survived for millions of years, yet we only know fragments of them. A civilization that relied on ephemeral materials, or even biological forms of technology, could vanish entirely. If intelligence does not leave hard, durable artifacts, it may leave nothing visible at all. The record is biased, preserved not for completeness, but for luck. Even our own technologies are fragile. In centuries, bridges collapse, skyscrapers crumble, roads fracture. In millennia, cities vanish beneath vegetation and erosion. Satellites fall, microchips corrode, plastics degrade. Only a few chemical anomalies, trace metals, or isotopic markers might survive, perhaps for millions of years. If our impact can be so subtle yet detectable, why could another intelligence not have existed hundreds of millions of years ago, leaving similar subtle traces that we misinterpret or overlook? The possibilities challenge our sense of uniqueness. We are new, a flicker in a vast continuum. Now imagine the oceans hundreds of millions of years ago, shallow seas teeming with soft-bodied organisms, trilobites scuttling along the seabed, primitive eyes reflecting sunlight, filter feeders sifting particles. Life was experimenting constantly. Some organisms evolved structures so complex we struggle to classify them today. What if intelligence also emerged in those seas? Perhaps a species manipulated its environment chemically, influenced ecosystems in subtle ways, or coordinated as a collective. They may not have needed tools like ours. Their technology could have been a behavior, a method of shaping life, a chemical manipulation that left no lasting structures. And yet, if we could find the faintest hints, a spike of metals, a disrupted sediment layer, we would be seeing them, almost accidentally, millions of years later. We tend to think of intelligence as creating obvious artifacts, carved stone, metal tools, monuments. But these are markers of human civilization, not universal requirements. Termites, beavers, and corals shape worlds in ways that are functional and intelligent, yet leave almost no permanent signature outside their lifetimes. If intelligence arose in a species whose medium was the ocean, the forest floor, or the soil beneath our feet, its creations could vanish as efficiently as the organisms that produced them. Time would smooth the traces, geology would remix the evidence, and we would see only natural processes, unaware of the deliberate influence that had once existed. Even in the fossil record, there are anomalies, shapes and patterns that puzzle scientists, out-of-place concentrations of elements, layered sediments that do not match expected processes. Most explanations are natural: lightning, volcanism, asteroid impacts. But the possibility lingers that some of these anomalies are the faint fingerprints of past intelligence. They are subtle, fragmentary, and often dismissed because they do not fit the standard narrative. Yet if we accept the premise that intelligence is not unique to humans, these subtle clues could represent entire chapters of history erased before we could read them. Standing on a cliff, feeling the wind touching the stone, you begin to understand why imagination becomes necessary. The Earth does not preserve its story as a narrative we can read. It offers fragments, puzzles, and whispers. And in those fragments, in those whispers, we can see the possibility that intelligence may have emerged again and again, flourished briefly, and then vanished. We are likely not the first, and perhaps not the last. The question is not whether it happened. It is how often it has happened, and how the echoes of that intelligence have been folded into the layers of the planet itself. Imagine a world long before the first dinosaur. Forests stretch across continents we no longer recognize, rivers carve paths that have been erased by shifting tectonics, and oceans rise and fall with rhythms that leave almost no trace. In this world, life experiments in every possible form, from the tiniest microbes to complex, soft-bodied creatures drifting in shallow seas. Some of these organisms leave traces in sediment, some in chemical shifts, but most leave nothing. Entire lineages vanish as if they were never there, yet their absence is also a kind of record. It tells us how fragile existence can be, how brief and delicate the spark of life is when viewed against the immensity of deep time. Now, imagine intelligence emerging here. Not human, not necessarily recognizable, but capable of shaping its environment. Perhaps it manipulates the chemistry of rivers, or engineers habitats, or develops systems of communication we would never recognize. What would remain of such a civilization hundreds of millions of years later? Almost nothing but whispers buried in rock, anomalies that challenge expectation, hints that seem natural until examined with imagination. The first thing to understand is that deep time is not linear. It is a sprawling, tangled web. Mountains rise and fall, oceans appear and vanish, continents drift and collide, and the crust itself is recycled by the relentless motion of tectonic plates. Land that existed in the Permian period might now lie under thousands of meters of ocean, subducted into the mantle, remelted, and resurfaced as new rock. The places where ancient intelligence could have flourished are largely lost to us. Any artifacts, tools, or constructions would be crushed, melted, or buried beyond recognition. Even a structure as durable as a steel skyscraper would not survive hundreds of millions of years. Time is the ultimate eraser. Yet hints can survive. Chemical anomalies, concentrations of metals, unusual isotope ratios. All these may persist long after the tangible structures are gone. Our own civilization, with just a few centuries of industrial activity, has begun leaving such fingerprints. Carbon released from burning fossil fuels has altered the ratio of isotopes in the atmosphere, and plastics and synthetic chemicals are finding their way into sediments worldwide. If we can leave detectable traces in a few centuries, It is plausible that another civilization, millions of years ago, could have done the same. The question is whether we would recognize it. Our expectations filter our perception. We look for stone ruins, tools, monuments. We do not always see what does not resemble our own path. Even in our limited fossil record, there are puzzles. Fossils that do not fit known species, chemical layers that hint at sudden environmental changes, rocks fused in ways that defy explanation. Most of these anomalies are explained naturally: volcanic activity, asteroid impacts, or mineral growth. But the possibility remains that some may be the faint echoes of intelligence long vanished. The Earth preserves not monuments, but patterns, subtle shifts in the chemistry and structure of the planet itself. In a sense, the planet is a palimpsest. The more deeply we look, the more we realize that what we see is a reconstruction built from chance, fragments, and interpretation. Imagine the oceans of the Devonian period. Soft-bodied creatures drift in currents, trilobites scuttle along the seabed, strange early fish swim among the reefs. In this dynamic environment, small pockets of intelligence could have emerged, navigating currents, communicating chemically, manipulating organisms, building ephemeral structures from shells or biological materials. Their constructions could have dissolved, decayed, or been buried without a trace. And if they did, the fossil record would offer almost no hint. Only careful analysis of chemical and mineral patterns might reveal their activity, subtle anomalies indistinguishable from natural processes to the untrained eye. Terrestrial life presents similar possibilities. Forests in the Carboniferous period were vast and oxygen-rich, with giant insects filling the skies. A species of intelligence could have developed in such an environment, leaving behind traces in ways that do not survive as fossils: altered soil chemistry, peculiar distributions of minerals, patterns in the growth of forests and swamps. Perhaps they experimented with building structures from wood, reeds, or other organic matter, all of which decay completely over millions of years. Perhaps their technology was biological, integrated into their bodies or ecosystems, dissolving back into nature as part of the planet's cycles. The lesson here is that our search for ancient intelligence is constrained by our assumptions. We expect evidence to look like our own civilization: tools, buildings, monuments. But intelligence does not require these markers. Termites build complex mounds, beavers engineer rivers, corals construct reefs, and octopuses manipulate objects skillfully, all without leaving traces that endure for millions of years. If intelligence emerged in another species long ago, it may have used strategies, materials, and methods we would not recognize. The planet may already contain evidence, but we may be blind to it. Time is the most ruthless force. A civilization that existed 300 million years ago would have been erased by erosion, tectonic activity, chemical alteration, and biological decay. Even if it reached industrial capability, its artifacts would have vanished, leaving only traces so subtle they are almost indistinguishable from natural anomalies. Carbon isotopes might hint at combustion, unusual metal concentrations might suggest processing, and shifts in sedimentation might reflect environmental management. Yet even these fingerprints are fragile and rare. The deeper the time, the less likely survival becomes. We are forced to imagine, to use creative reasoning grounded in the science we know. We visualize species shaping rivers, engineering habitats, experimenting with materials designed to return to the environment, all in ways that leave little permanent mark. We consider oceans teeming with intelligence, forests alive with cunning, creatures whose cognition was alien to us, yet no less capable of ingenuity. We realize that absence of evidence is a weak argument, and that silence does not equal emptiness. The earth has erased more than it has preserved, and in the gaps, possibilities abound. The recognition of these possibilities reshapes our perspective. Humans are no longer the first flicker of intelligence. We are the latest spark, arriving on a stage that has been lit before and extinguished repeatedly. The question is not whether intelligence has occurred previously. It is how often it has, how fully it has flourished, and how little has survived. Perhaps civilizations have come and gone like waves, rising briefly, shaping the world subtly, and then dissolving entirely into time. Our own civilization may one day vanish similarly, leaving only faint chemical traces, a whisper in stone, a shadow in the sediments. Look at a canyon wall and notice the layers of rock stacked like pages in a book no human will ever finish reading. Each stratum is a fragment of a world that once existed, a tidal flat, a forest floor, a river delta, an ocean basin. Time presses upon these pages relentlessly, folding, crushing, eroding, recycling them into new stone. The deeper we reach into these layers, the less we understand. What we see is partial, fragmentary, often misleading. We interpret shapes and chemical compositions, but the interpretation is a human lens applied to a world that is indifferent to our perspective. Within these fragments, there may have been intelligence, a species capable of shaping its environment, of creating patterns, tools, and communities. And yet, even if they existed, the Earth would have almost certainly erased everything tangible. Consider the oceans hundreds of millions of years ago. Shallow seas teem with trilobites, soft-bodied creatures, and the first fish, all experimenting with forms and behaviors that would vanish almost entirely from the fossil record. Perhaps among them, some organism or network of organisms achieved awareness, using biological tools, modifying ecosystems, or creating structures that dissolved back into the environment. Imagine chemical signals guiding colonies, coordinated behaviors shaping habitats, subtle manipulations of their surroundings. Millions of years later, the sediment might show unusual concentrations of minerals or chemical anomalies, hints so subtle we might dismiss them as natural fluctuations. Yet they could be the only footprints left of intelligence. On land, forests and swamps dominate the Carboniferous world, thick with oxygen, buzzing with giant insects, crawling with amphibians, and populated with early reptiles testing new strategies for survival. A species could have emerged here, perhaps walking, perhaps gliding, perhaps entirely alien in form. It may have developed tools, not of stone or metal, but of organic materials, structures that returned to the soil as they decayed. Entire villages, laboratories, or gathering places could have vanished without leaving a mark. We assume intelligence produces permanence, but deep time challenges that assumption. The more ephemeral the materials, the more completely time erases them. Even durable structures would succumb. Steel corrodes, glass shatters, concrete crumbles. Mountains themselves rise and fall over millions of years. Oceans flood valleys and swallow coasts. Tectonic plates drag the crust down into the mantle. A civilization that thrived hundreds of millions of years ago could have been buried beneath kilometers of rock, transformed by heat, pressure, and chemical reactions, leaving no recognizable trace. The silence we observe is not necessarily evidence that nothing happened. It may simply be the product of Earth's relentless editing. Our search for evidence is further constrained by expectation. We look for things we understand: straight lines, manufactured objects, carvings, inscriptions. But intelligence might not produce recognizable artifacts. It might manipulate biology, chemical systems, or the environment in ways that vanish as soon as they are created. Consider beavers building dams or corals forming reefs. The result is complex, functional, and durable only insofar as nature preserves it. A species hundreds of millions of years ago could have applied intelligence in similar subtle ways. Their work might have altered currents, soils, or ecosystems, leaving patterns we mistake for natural processes. The record of intelligence may have been hidden in plain sight all along. The fossil record is incomplete. Even massive species like the dinosaurs are known from fragments. Whole ecosystems, lineages, and continents have disappeared without a trace. Preservation is the exception, not the rule. And yet, chemical signatures can persist. Carbon isotopes, trace metals, rare earth elements, even unusual sedimentation patterns can remain in rock layers for hundreds of millions of years. These are the whispers left behind by life and possibly intelligence, subtle and easy to miss, interpreted as natural anomalies, but hinting at events that defy conventional explanation. Imagine a civilization with technology, not in the form of skyscrapers or satellites, but integrated into life itself. Their tools might be biological, self-repairing, dissolving into ecosystems after use. Their energy sources could be photosynthesis, chemical gradients, or geothermal processes, leaving no scorch marks, no smog, no ruins. They could have communicated chemically, visually, or through vibrations undetectable to humans. Their intelligence might have been episodic, emerging and fading as environmental conditions shifted. Millions of years later, the evidence would be buried, obscured, and nearly impossible to recognize. Yet the possibility of their existence changes how we interpret silence. Even anomalies we have found may hint at these possibilities. Metallic spheres, unusual isotopic ratios, vitrified rock layers, all can be explained naturally, yet each raises the question: could these be faint echoes of past intelligence? Could chemical shifts in ancient sediments, once attributed to volcanic eruptions or asteroid impacts, partially reflect industrial-like activity? The answer is uncertain, but the question itself forces us to confront the scale of deep time and the fragility of evidence. We cannot assume the record is complete. The past is full of experiments, failures, and vanished civilizations. When we imagine ourselves vanishing, the picture is sobering. Cities crumble, satellites fall, books decay, servers rot, and the Earth begins reclaiming everything immediately. The chemical footprint, subtle as it may be, might persist, but almost all physical evidence disappears. Now, scale that scenario to a civilization hundreds of millions of years old. We understand why evidence would be scant. And yet, the possibility remains that intelligence has emerged before, shaped its world, and then disappeared into the machinery of deep time. Standing on a cliff, Looking at layers of rock or in a fossil bed, the imagination is required. The fragments, chemical anomalies, and unusual formations may represent lost intelligence, entirely invisible to conventional expectations. The silence of the past is not proof of absence. It is the canvas on which possibility can be projected. Intelligence may have flickered countless times, leaving barely perceptible traces for a future observer. And perhaps we are the latest spark in a chain we can barely perceive, standing atop the sediment of civilizations we may never know. Whenever the idea of a civilization long before humans is raised, the natural reaction is to ask, where are their artifacts? It feels like the most obvious question. If beings intelligent enough to shape their world existed millions of years ago, why do we not find their tools, their structures, their machines? But artifacts are fragile bridges across time. Even our own artifacts, the ones we imagine to be durable, are astonishingly temporary when measured against geological time. The longer we stare into the abyss of millions and billions of years, the clearer it becomes. Absence of artifacts is not absence of history. It is simply evidence of the Earth's endless ability to recycle, erase, and transform. Consider how fragile material culture really is. Wood rots in decades. Cloth and leather disintegrate in a matter of years, unless preserved in rare conditions of dryness or cold. Paper becomes brittle, ink fades, rope and fiber crumble. Even metals, which we think of as strong, cannot resist time. Iron rusts quickly, aluminum corrodes, copper oxidizes, and bronze weathers into green fragments. Glass can survive longer, but it too becomes brittle, cracked, and powdered. Plastics, which we imagine as eternal, degrade under sunlight and heat, eventually fragmenting into smaller and smaller pieces. Only stone seems truly durable, but even stone wears down, fractures, dissolves under rain and frost. Now imagine artifacts not over centuries or millennia, but across millions of years. A city would collapse, its rubble scattered, eroded, buried. Sediments would layer over it, compressing and transforming the remains. Tectonic plates might drag the region downward, melting everything into magma. Volcanoes, earthquakes, and erosion would erase all traces. If we vanished tomorrow, how long before our artifacts disappeared entirely? Perhaps within 10,000 years, little would remain but a scattering of stone. Within 1,000,000 years, even that would be difficult to recognize. Stretch further into hundreds of millions of years, and the probability of survival approaches zero. Yet sometimes, artifacts do survive. We have discovered tools made of stone, pottery shards, cave paintings, and bone implements from thousands or tens of thousands of years ago. These feel ancient to us, but they are recent scratches on the vast timeline of Earth. They survived because they were made of durable material and buried in favorable conditions. They are the exceptions, not the rule. And even then, our record is incomplete. Whole cultures are known only through fragments. Others are lost entirely because their materials did not last. Archaeology teaches us humility. What we know is only a sliver of what once existed. Extend that lesson backward into the abyss of deep time. If a civilization existed hundreds of millions of years ago, most of its artifacts would not have survived. Even if a few objects did endure, how would we recognize them? Over millions of years, an iron tool could oxidize into a reddish lump indistinguishable from natural mineral deposits. A glass object could fracture into grains that look like quartz. A complex machine could disintegrate into trace elements scattered within rock. To our eyes, the artifact would have become geology. Unless we knew exactly what to look for, we would pass it by without notice. This problem is compounded by bias. Scientists are trained to expect natural explanations, and rightly so. Extraordinary claims require extraordinary evidence. So when an anomaly arises, an unusual pattern in rock, a metallic sphere with grooves, a shape embedded in coal, it is usually explained conservatively. Perhaps it is a natural crystal, a mineral vein, a concretion formed by pressure, and often that is correct. But what if, in rare cases, the anomalies are something else? What if they are the degraded remnants of artifacts so old they no longer resemble their original form? We would never know unless we asked the question, unless we allowed for the possibility that not every anomaly is natural. There have been reports of so-called out-of-place artifacts, objects claimed to be found in geological layers far older than humans, nails in stone, figurines in coal, spheres in ancient rock. Many of these claims are dubious, unsupported, or proven hoaxes. But some remain unexplained, lingering at the edges of credibility. Science tends to dismiss them rather than embrace uncertainty, preferring the comfort of natural explanations. And perhaps that is wise. Yet the possibility remains. Even if only one of those anomalies were genuine, it would rewrite everything we believe about Earth's history. The difficulty is that artifacts degrade not only physically, but interpretively. Even if we discovered something undeniably artificial in a 300-million-year-old rock layer, how would we interpret it? Would we recognize its significance, or would we assume contamination, error, or misidentification? The further back in time we look, the less willing we are to entertain the possibility of intelligence. Our skepticism, though healthy, may also blind us. We see what we expect to see, and we dismiss what does not fit. Artifacts, then, are not only fragile in their survival, but fragile in our recognition of them. Imagine for a moment that deep beneath a coal seam lies the mineralized remnant of a tool or a structure, distorted beyond recognition, its original purpose lost to time. A miner chips it free, puzzled by its unusual shape, and tosses it aside as a curiosity. Or imagine a geologist cataloging an odd metallic deposit, never suspecting it is the residue of something once shaped with intention. These moments may already have happened. The evidence may have already crossed our hands, unnoticed, dismissed, forgotten. The Earth doesn't hide its history out of malice. It simply transforms it until meaning is almost impossible to extract. The irony is that our own civilization may meet the same fate. If we vanish, our artifacts will decay, erode, and vanish. Perhaps a few remnants will survive in unusual conditions, but most will be gone. Millions of years from now, if another species asks, "Where are their artifacts?" the answer will be the same: gone, erased, transformed into geology. They might find anomalies, strange concentrations of plastic polymers, unusual isotopes, metallic residues, but not cities, not machines, not monuments. And they, too, might dismiss the anomalies as natural. The cycle repeats. Artifacts are lost, civilizations vanish, and silence fills the gaps. So when we ask why there are no artifacts of ancient civilizations before us, the answer is not that they never existed. The answer is that artifacts are temporary, fragile, and vanishingly rare across deep time. What remains is not the object itself, but the faintest of echoes, chemical hints, geological puzzles, anomalies that whisper rather than shout. We may never find clear proof, but perhaps that is the nature of history on this planet. The Earth is not a keeper of relics. It is a destroyer of them. And in its silence lies the humbling possibility that intelligence has walked here before, leaving behind only the faintest shadows in stone. When we imagine tools, we think of flint blades, stone axes, bronze daggers, iron swords. These artifacts feel ancient to us, and yet they belong to the last few thousand years, a sliver of time compared to Earth's 4.5 billion-year history. The oldest stone tools we know, shaped by early hominins, are about 3.3 million years old. To us, they are unimaginably distant. To the planet, they are yesterday's scratches on the surface. If such tools, made of stone, can survive millions of years, then we assume anything older must also reveal itself. But what if the first tools were not stone at all? What if intelligence began experimenting with the world long before bones and skeletons evolved, when organisms themselves were soft, delicate, ephemeral? The oldest tools might have been softer still, sticks sharpened for digging, shells adapted for scraping, or structures formed from organic materials that dissolved before they could fossilize. If such tools existed, they are gone without a trace, erased more thoroughly than the bones of the creatures who wielded them. We define tools by our own experience, objects shaped intentionally to extend ability. But intelligence does not have to look like ours. A crow dropping nuts onto asphalt to be cracked by car tires is using the world itself as a tool. An octopus carrying coconut shells to use as armor is doing the same. These acts do not leave behind artifacts, they leave behind behaviors. If intelligence existed millions of years ago, we may never find its tools because those tools were behaviors, patterns, choices, and ephemeral objects designed for immediate use, not permanence. Our search for chipped stone or carved bone blinds us to the possibility that ancient intelligence may have expressed itself differently. Even within human history, most tools are gone. Entire cultures have disappeared without leaving a single artifact. The earliest baskets, clothing, woven mats, wooden structures, all vanished. We know they existed only because fragments survived in rare, dry caves or were preserved by fire. Otherwise, the archaeological record would show only the durable exceptions: stone, pottery, bone. That is the preservation bias. It means we overvalue what survives and underestimate what has been lost. Extend that bias across hundreds of millions of years, and the imbalance becomes overwhelming. We see nothing not because nothing existed, but because almost everything is gone. Imagine a Devonian shoreline 400 million years ago. Strange fish dart in shallow waters, primitive plants cling to rocky outcrops, early arthropods scuttle in the mud. If an intelligent lineage arose here, perhaps experimenting with shells, bones, or hardened secretions as tools, those tools would have been scattered, broken, decomposed. A sharpened shell might be indistinguishable from a naturally fractured one. A hardened secretion used for digging might fossilize in a way we would mistake for ordinary biology. Unless tools were made from stone and left in favorable conditions, their traces would vanish into the noise of geology. Tools older than bones may be invisible, not because they did not exist, but because we cannot recognize them. And even if such tools survived, interpretation is fragile. A chipped stone found in a fossil bed might be dismissed as a natural fracture. A strange groove on a shell might be catalogued as erosion. A mineralized lump with unusual symmetry might be stored away as a curiosity, never re-examined. The problem is not only survival, but recognition. We expect certain shapes, certain patterns, and if what we find does not match those expectations, we look past it. We may already have uncovered fragments of tools older than bones without realizing their significance. They may sit in drawers of museums, labeled vaguely, unexplored, waiting for a new question to reframe them. The irony is that tools, so central to our sense of progress, are among the least likely to endure. Fire, the earliest tool of human civilization, leaves almost no permanent trace. Wood and fiber decay. Metal corrodes. Only stone endures, and even then only by chance. If ancient intelligence took a different path, one focused on perishable materials, ephemeral behaviors, or biological integration, then its tools may have vanished completely. To imagine tools older than bones is to imagine intelligence expressed in forms that do not fossilize. And if that is true, then the silence of the past is not a denial, but an artifact of our own blindness. Think again of the octopus, crafting solutions without permanence, or the crow, using cars to crack nuts, or the beaver, reshaping rivers without machines. These are not lesser intelligences. They are different intelligences. They remind us that the story of tools is not fixed. It is flexible, adaptive, fleeting. If creatures like these had millions of years to evolve in a world untouched by us, who is to say they would not have developed tools of their own, tools we would never see because they dissolved into the soil, vanished into the tide, or were mistaken for natural shapes? This is what makes deep time so haunting. It suggests that the story of intelligence may be older than we think, hidden in eras we barely understand. We may be searching for the wrong evidence, demanding artifacts when the real evidence was always behavioral, ephemeral, dissolving into the fabric of life. If tools older than bones once existed, their absence today does not mean they were never real. It means time did what it always does. It erased them, folded them into rock, and left us with silence. There is a strange paradox in the search for ancient intelligence. The very evidence we seek may have been hidden by the same processes that make Earth so vibrant and alive. Planets that are geologically dead, like the Moon or Mars, preserve their surfaces for billions of years. A footprint on the Moon can last an eternity, untouched by wind or rain. But Earth is alive with erosion, tectonics, weather, and biology, and that very liveliness erases its past. It is why we find so few fossils compared to the countless species that once lived. It is why most of the planet's crust is younger than 200 million years. And it is why, even if a civilization rose long before us, its memory might have been consumed by the planet itself. Think about the concept of geological recycling. At subduction zones, entire slabs of crust dive beneath one another, dragging mountains, forests, rivers, and any trace of human or pre-human construction into the mantle. There, under heat and pressure, rock melts, reforms, and eventually emerges again as new volcanic material. What once might have been a city becomes magma, indistinguishable from the rock around it. This is not destruction in a single catastrophic moment, but in a slow, patient process that ensures nothing on the surface lasts forever. Even continents are not permanent. They drift, collide, fragment, and vanish. The places where ancient intelligence might have flourished may no longer even exist as land. And yet, even as Earth erases, it also records. It does so in ways that are subtle and indirect. Sedimentary layers capture changes in climate, chemistry, and biology. Ice cores trap bubbles of ancient air. Isotopes in rocks reveal massive transformations in the atmosphere. When something extraordinary happens, even if its physical evidence is destroyed, its shadow lingers in the chemistry of the Earth. That is why scientists study isotope ratios, carbon levels, and trace elements. These are the whispers that survive when stone, bone, and artifact are gone. Our own civilization is leaving such whispers now. The combustion of fossil fuels alters the ratio of carbon isotopes in the atmosphere and sediments. Synthetic chemicals, plastics, and heavy metals seep into soils and oceans. Nuclear activity leaves behind isotopes that will persist for millennia. Millions of years from now, these subtle fingerprints may be the only evidence that we ever existed. They will not show our buildings, our art, or our machines. They will show a chemical anomaly, a thin line in the rock, a disruption in the pattern of sediments. Future scientists, whoever or whatever they are, may debate their meaning without ever suspecting the full truth. This humbles us. It reminds us that civilizations do not write their legacies in monuments alone. They write them in the chemistry of the planet. And if this is true for us, then perhaps it was true for others. If another intelligence once existed here, its evidence would not be statues or skyscrapers. It would be anomalies, unexplained spikes in carbon, unusual distributions of metals, sudden changes in sedimentation. These would be subtle, ambiguous, and easy to dismiss. We may already have seen them. We may already have catalogued them as volcanic eruptions, methane releases, or asteroid impacts. And perhaps most were exactly that. But perhaps one or two were not. Perhaps they were the echoes of intelligence, erased physically but preserved chemically. Think of the Great Oxidation Event 2.5 billion years ago, when cyanobacteria transformed the planet by producing oxygen. To earlier life, oxygen was poison, and the event caused a mass extinction. To us, it was a gift, without which we could not exist. But here is the lesson. A microscopic species, invisible and simple, altered the entire atmosphere of the Earth. Their presence is still detectable billions of years later, not through fossils of their bodies, but through the chemistry they left behind. If microbes could leave such a lasting signature, what could a civilization do? And what if one already has? The record of mass extinctions also carries mysteries, abrupt die-offs, sudden shifts in carbon, rapid changes in ecosystems. Most are attributed to natural catastrophes, volcanism, asteroid impacts, climate shifts. But what if, in at least one case, the cause was not natural? What if it was the collapse of an ancient intelligence, its own activity destabilizing the planet's systems, leaving behind nothing but chemical disruption? To us, it would look no different from any other extinction. We would never know, unless we ask the question. And so the paradox sharpens. Earth erases physical evidence, even as it preserves chemical memory. We search for artifacts but find anomalies. We crave monuments but are left with whispers. And in those whispers may lie the traces of civilizations erased so completely that their only legacy is a distortion in the deep record of the Earth itself. Standing on the edge of a desert, watching wind strip sand from stone, You feel this paradox. The desert seems eternal, but dunes shift daily, mountains wear down over millennia, and entire landscapes vanish over millions of years. If an ancient intelligence walked here, building with wood, clay, or even stone, nothing would remain. But the soil might hold traces of unusual chemistry. The rocks might preserve a line of carbon or metal. The silence of the desert is deceptive. It is full of echoes if only we learn how to listen. Perhaps this is the greatest lesson deep time offers. Civilizations are not preserved in monuments. They are preserved in anomalies. They are written not in visible ruins, but in the chemistry of stone, in the subtle distortions of Earth's record. We may never find the artifacts we crave, but if we accept the Earth's way of remembering, we may already be looking at the fingerprints of civilizations older than bones. The Earth has seen 5 great mass extinctions, and each one acts like a hammer striking a gong, reverberating through the history of life. The Ordovician wiped out most marine species. The Devonian devastated fish and reefs. The Permian nearly sterilized the planet, erasing 90% of all life. The Triassic cleared the way for dinosaurs, and the Cretaceous ended their reign, making room for mammals. Each extinction was both an ending and a beginning. Each one was an opportunity for intelligence to rise and a threat to any intelligence already present. We look back at these extinctions as geological events, explained by volcanoes, asteroids, climate shifts. But what if at least one of them was not purely natural? What if an ancient intelligence played a part in its own downfall, much as we risk doing now? Consider the Permian extinction, the greatest of all. Evidence points to massive volcanic activity in what is now Siberia, releasing carbon dioxide, heating the climate, acidifying the oceans. Yet some scientists argue that the scale of carbon released seems almost industrial in its intensity, like a planet-wide burning of fuel. Imagine if, before the Permian ended, a species had discovered how to harness energy on a large scale. Their combustion, their mining, their alteration of ecosystems could have amplified natural events, tipping the balance into catastrophe. To us, the evidence looks like volcanism. To them, it might have been their own Anthropocene, a crisis of their making, ending in silence. Even the Cretaceous extinction, usually blamed on an asteroid, offers strange possibilities. The impact did occur. There is a crater, a layer of iridium, a global scar. But was the planet already vulnerable? Some studies suggest ecosystems were stressed before the asteroid struck. If another intelligence existed in that era, perhaps their activity weakened the world, making it less resilient to impact. Their presence would be invisible now, erased with their bodies and their works. All we see is the asteroid, the firestorm, the sudden darkness. Yet history is rarely simple. Catastrophes are often layered with multiple causes. Perhaps intelligence was one of those causes once before. This possibility forces us to look at our own time differently. We see ourselves as unique, a civilization at the edge of cosmic discovery, able to shape the planet. But perhaps we are only the latest in a cycle. Intelligence rising, flourishing, destabilizing its world, and collapsing. Each time, the Earth absorbs the traces, turning ruins into stone, turning machines into minerals, turning histories into silence. Each time, the next intelligence rises unaware of the last, imagining itself alone, special, singular. The cycle continues, not because intelligence is rare, but because survival is fragile. Think of the irony. What we consider our triumphs, our industry, our power, our reach, may also be our undoing. We burn, we dig, we consume, and in doing so, we alter the balance that sustains us. The same may have happened before. Another intelligence, another civilization, perhaps alien in form but familiar in ambition, may have followed the same path, reaching heights of power only to trigger its own collapse. If so, then the mass extinctions we read in rocks are not just natural events, but epitaphs of intelligence past. Even if intelligence was not the cause, extinctions would still have erased it. The asteroid that ended the Cretaceous would not have spared an intelligent species any more than it spared the dinosaurs. A firestorm sweeping the globe, tsunamis crashing across continents, darkness lasting years. Such a catastrophe would annihilate not only bodies, but cultures, languages, and knowledge. Within a few centuries, nothing would remain but fragments, scattered and buried. Within a few million years, even those fragments would vanish. We would see only the line of iridium, the fossils of shocked quartz, the sudden absence of species. The intelligence that once dreamed under that sky would be gone without a trace. Mass extinctions are reminders that permanence is an illusion. Even the most advanced species cannot protect itself against the scale of planetary catastrophe. Volcanoes, impacts, shifting climates. They are larger than any civilization, larger than any technology. If intelligence has risen before, it has faced these challenges, and it has lost. We might be next. And yet, extinctions also open doors. After the Permian, new species rose to dominate. After the Cretaceous, mammals expanded into niches left empty by dinosaurs. Each ending is a beginning, and each beginning is a chance for intelligence to emerge again. Perhaps that is why Earth may have produced intelligence more than once. Perhaps it is not a miracle, but a rhythm, a possibility that recurs whenever conditions align. The question is not whether intelligence existed before, but how many times it has flickered into being, only to be erased by catastrophe or by its own hand. Stand on a rocky shore, waves crashing, wind carrying the smell of salt and the cries of gulls. You are standing on a planet that has ended worlds many times before. Each wave, each gust, each grain of sand carries the memory of destruction and renewal. Civilizations, if they existed, have been erased here, their stories dissolved into stone. And yet, the possibility of their existence shapes how we see ourselves. We are not the first to face fragility. We are not the first to live under the shadow of extinction. We may not be the last. This realization is sobering, but it is also liberating. It tells us that intelligence is not a final destination, not the crown of evolution, but a fragile experiment. The Earth has run that experiment before and will run it again. Our task is not to prove we are the first, but to decide whether we will be the last. Mass extinctions remind us that survival is not guaranteed. They remind us that memory is fragile, and that silence is the Earth's default. In that silence, perhaps civilizations once spoke, dreamed, and vanished. Legends linger in human memory like shadows of forgotten dreams. From the stories of Atlantis described by Plato to the cyclical ages of destruction and rebirth told in Hindu texts, from the flood myths of Mesopotamia to the tales of vanished worlds in Mesoamerican lore, cultures across the globe have carried whispers of civilizations lost. We usually treat these stories as metaphor, allegory, or myth. Yet myths often contain kernels of memory, distorted through centuries of retelling. What if, buried inside these tales, there are faint echoes of something older than human history? Memories not of human civilizations, but of civilizations erased by deep time. Take Atlantis. To Plato, it was a powerful island nation that sank beneath the waves in a single night and day. Scholars argue it was allegory, a cautionary story about pride and downfall. But the resonance of the myth has endured because it touches something deeper, a fear of fragility, of worlds swallowed by catastrophe. Humans may have invented Atlantis, but perhaps the very idea of a lost civilization is older than us, arising from a collective intuition shaped by the silence of the earth itself. We sense that civilizations vanish because the ground beneath us remembers, even if we do not. In Mesopotamia, the Epic of Gilgamesh speaks of a flood that destroyed the world, sparing only a chosen survivor. In the Hebrew Bible, Noah builds an ark against the same deluge. In Hindu tradition, Manu survives a flood that resets creation. In Mesoamerican myths, previous worlds are destroyed in fire, water, or darkness before the current age begins. These are not the same story repeated, but variations on a theme. The idea that civilizations rise and fall, that worlds end and begin again. We assume these stories arose from human memory of regional floods and disasters. But what if they also echo something larger? The rhythm of Earth itself, the endless cycle of creation and erasure. Even philosophy has touched on these possibilities. The ancient Greeks spoke of eternal return, the idea that history repeats itself endlessly. Indian philosophy speaks of yugas, cosmic ages that rise and fall in cycles, each ending in destruction before renewal. The Aztecs spoke of suns, worlds created and destroyed in succession. These frameworks of thought, arising independently across culture, all point toward the same intuition: that we are not the first, that others have come before, that existence itself is cyclical. Perhaps these philosophies arose not purely from imagination, but from a dim recognition of truths buried in the Earth's silence. Archaeology sometimes stumbles upon mysteries that feed these myths. Ancient structures aligned with stars, megaliths whose purpose is unclear, carvings that seem to record knowledge too advanced for their time. Most of these puzzles have explanations, but some remain stubbornly ambiguous. Our impulse is to connect them to lost civilizations of humans. Yet the deeper possibility is even more haunting: that such myths persist because the idea of lost civilizations resonates with a reality older than humanity. Perhaps deep within our collective psyche is the intuition that the Earth has seen intelligence before and erased it. The danger lies in confusing myth with fact. Ancient alien theories exploit this terrain, attributing human achievements to visitors from the stars. But perhaps the truth is stranger and closer. Maybe the lost civilizations we imagine were not extraterrestrial at all, but terrestrial, erased so completely by time that only myths carried subconsciously across cultures remain. Not memories of specific events, but archetypes of fragility. Stories shaped by the Earth's relentless habit of destruction and renewal. If myths are whispers of forgotten civilizations, then geology is the archive of their erasure. The Great Flood may echo the end of the last ice age, when melting glaciers raised sea levels and swallowed coastlines where early humans lived. But perhaps the story resonates so strongly because floods have ended worlds many times before, erasing not only villages, but possibilities of intelligence long vanished. Fire, too, is a recurring theme. Volcanoes, wildfires, or impacts, darkness and famine repeat across mythologies, mirroring the aftermath of real catastrophes. Each time the world seems to end, memory carries the warning forward. And perhaps memory carries further than we think. There is a haunting symmetry between myth and geology. Geology tells us the Earth has ended worlds repeatedly. Myth tells us the same, through stories of floods, fires, and destruction. The two may not describe the same events, but they echo each other, as though myth is the emotional counterpart to geology's cold record. Together, they suggest a truth we cannot ignore. Civilizations, whether human or pre-human, are fragile. The Earth does not preserve them. It buries them, drowns them, burns them, forgets them. And yet through myth, the idea survives. We keep telling stories about lost civilizations because the planet keeps erasing them. Standing in the ruins of an ancient temple, wind whispering through broken columns, you feel this resonance. The temple is not millions of years old. It is only thousands. But it feels timeless because it embodies the fragility of permanence. The stones are weathered, inscriptions fading, carvings eroded. Even here, in human history's shallow time, we see how quickly civilizations vanish. Multiply that by hundreds of millions of years, and the silence becomes deafening. Myths survive where artifacts do not, because stories can leap across generations even when stone cannot. And maybe, just maybe, the myths we carry are shadows of stories older than us, older than humanity, older than bones. Perhaps the real lesson of myth is not that Atlantis was real or that a single flood reset the world, but that loss is inevitable. Civilizations vanish, worlds end, the earth erases, and all that remains are whispers. Those whispers take form in myth, in legend, in philosophy. They remind us that permanence is an illusion, and that intelligence may have risen before, not once, but many times. We listen to these myths not for proof, but for resonance. They resonate because they mirror the Earth's truth. Intelligence is fragile, civilizations are temporary, and the silence of deep time has swallowed more than we will ever know. When we imagine the search for lost civilizations, our minds drift outward, toward the stars. We wonder about ancient visitors, ships descending from the sky, alien architects shaping pyramids or teaching humanity its first steps. But perhaps we are looking in the wrong direction. The question is not only whether intelligence has come from beyond, but whether intelligence has risen here before, born of this earth, nurtured by its oceans and soils, extinguished by its catastrophes. Ancient aliens may be unnecessary if ancient earthlings once existed. The mystery is not only cosmic, it is terrestrial. The earth itself is stranger than we admit. Beneath our feet lies a dynamic system of tectonic plates, oceans cycling through the crust, volcanoes exhaling the planet's interior. Life and geology intertwine so thoroughly that to separate them is almost impossible. Microbes alter the atmosphere, plants shape the climate, and humans now rearrange ecosystems and chemistry on a global scale. If we can transform a planet in a few centuries, why could another intelligence not have done the same millions of years ago? Perhaps the difference is that their fingerprints are now misread as natural events. Consider the idea of the Anthropocene, the proposed new epoch marked by human activity. Geologists debate when it began: industrialization, nuclear testing, or earlier agriculture, but all agree that human civilization is leaving a permanent mark on the stratigraphic record. Plastics, concrete, fly ash, carbon spikes, radioactive isotopes, these will be detectable long after our cities vanish. Imagine another intelligence leaving its own scene millions of years ago. Their traces might be similar: chemical anomalies, sudden shifts in sediments, strange isotopic ratios. We would interpret them as volcanic events, methane releases, or asteroid impacts, and perhaps most were exactly that. But if one or two were not, we would have no way of knowing. This is the core of the Silurian hypothesis, posed by modern scientists not as proof, but as a thought experiment. Could we detect an ancient industrial civilization if it had existed? The unsettling answer is that the evidence might be indistinguishable from natural processes. Even if a species had mastered energy, industry, and technology millions of years ago, almost all of its artifacts would be gone. What would remain are subtle signals, easily misinterpreted. The Earth's record is not a history book, but a palimpsest, rewritten again and again, each new chapter erasing most of the last. And if intelligence has flickered here more than once, the implications are profound. It means that we are not unique, not the first, and perhaps not the last. It means intelligence may be a recurring experiment, one that Earth conducts whenever conditions align, only to erase the results when balance tips or catastrophe strikes. To see ourselves as part of that cycle is both humbling and terrifying. It suggests that our own Anthropocene may be temporary, just another thin line in stone, another anomaly debated by future minds who wonder what happened here. Think of Mars, a planet where rivers once flowed and seas may have existed. Its surface is scarred but largely unchanged for billions of years. If intelligence ever arose there, its artifacts might still survive, frozen, preserved by geological stillness. Earth offers no such preservation. Our planet is alive, vibrant, and therefore forgetful. It erases relentlessly. What remains are not ruins but whispers, subtle anomalies buried in rock, scattered clues awaiting interpretation. This is why the search for ancient intelligence on Earth is not only archaeological but philosophical. It forces us to confront what intelligence means, how it expresses itself, and how it leaves traces. We are biased toward seeing ourselves as the measure, expecting tools, writing, and monuments. But intelligence may not always produce those things. It may produce behaviors, ecosystems, chemical shifts, or ephemeral technologies designed to vanish. And if that is true, then the silence of the past is not empty. It is full of possibilities we cannot yet recognize. Standing under a night sky, looking at stars, we imagine civilizations beyond. But perhaps the stars are mirrors, and the real mystery lies beneath our feet. Earth may be a graveyard of intelligences, each erased by time, each leaving behind only faint signals. We are one more voice in that chorus, singing briefly before silence resumes. The unsettling question is not only whether others came before, but whether others will come after. If we vanish, will Earth give rise to intelligence again? Will some future lineage, bird, octopus, machine, or something we cannot imagine, look back and wonder if they were the first? Will they stumble upon chemical anomalies from our era and ask the same questions we ask now? Perhaps the cycle will repeat, as it has before, as it will again. and so the boundary between ancient aliens and ancient earthlings blurs. We do not need to look to the stars to find mystery. The Earth itself is strange enough. It has run countless experiments, erased countless stories, and buried countless possibilities. If civilizations existed here before us, they are now part of the stone beneath our feet, part of the chemistry in the air, part of the silence of deep time. The stars may hold other intelligences, but so may the Earth itself. Intelligence is not in the sky above, but in the ground below, forgotten, erased, waiting only for us to wonder. When we speak of deep time, we often treat it as abstraction, an incomprehensible scale we measure with numbers but cannot truly feel. 4.5 billion years, 5 mass extinctions, countless shifts of continents. These are statistics, almost sterile in their enormity. But stand before a cliff face where layers of rock are revealed, and suddenly the abstraction becomes physical. You can touch it. You can place your hand on a band of stone that was once an ocean floor 300 million years ago. You can rest your palm against a layer of limestone that formed from the shells of creatures that lived and died in a world without humans, without dinosaurs, perhaps without forests. And between these layers there are gaps, blank pages, intervals where entire histories may have been written and then erased. In those blank pages lies the haunting possibility of civilizations that came and went before us. We imagine ourselves as the culmination, but the Earth's indifference tells another story. It has erased more than it has preserved. The fossil record is a patchwork quilt, stitched from rare survivals. 99% of all species that have ever lived are extinct, most leaving no fossil record at all. If even the great beasts of the past are known only in fragments, what chance does a civilization have, especially if it used materials designed to vanish, or technologies that left no durable residue? The silence of the rocks may not be emptiness. It may be amnesia. And perhaps we should take that lesson personally. Our own civilization, as vast as it feels, is just as fragile. Cities will collapse, machines will rust, archives will vanish. What will remain? A chemical fingerprint, plastics fused into stone, isotopes from nuclear reactions, a spike in carbon from burning fossil fuels. To future beings, these will look like anomalies, thin lines in the geological record. They may never know who we were, what we dreamed, what we built. They may debate whether intelligence ever existed in our era, just as we debate whether it existed before. The mirror is cruel because it shows us not only the past, but our own impermanence. This is why the possibility of forgotten civilizations matters. It is not only speculation about the past, it is a reflection of our own future. If intelligence has risen and fallen before, then our survival is not guaranteed. If Earth erases its stories so completely, then our own story may vanish the same way, swallowed by stone, remembered only in anomalies. We imagine ourselves immortal, but geology teaches otherwise. The most advanced machines will become dust. The greatest monuments will become sand. The proudest archives will rot. The Earth will forget us, as it may have forgotten others. Yet there is also something beautiful in this cycle. Intelligence is not a singular miracle. It is a possibility that recurs, like lightning in a storm. Each spark is brief, each flare temporary, but the storm itself continues. Perhaps Earth has lit this flame many times before. Perhaps it will light it again after us. We are not the first voice in the chorus, nor the last. We are a note in a song that spans eons, a melody of awareness that rises, falls, and rises again. The silence of deep time invites imagination, but it also demands humility. We cannot claim certainty. We cannot prove lost civilizations existed, but we can acknowledge the fragility of evidence, the biases of preservation, the indifference of geology. We can accept that what we know is partial and what we do not know may be vast. And in that acceptance, we find wonder. The possibility that we walk on the graves of forgotten civilizations, that we breathe the air once breathed by minds erased, that we live in a world haunted not by ghosts, but by silence. That possibility expands our vision of history. Stand in a desert where the wind sculpts dunes into shifting forms. Stand on a mountaintop where ancient rocks bear the scars of fire and pressure. Stand in a rainforest where life pulses in chaotic abundance. In each place, imagine what once was, what may have been, what has been erased. Civilizations, if they existed, are gone, but the earth carries their echoes in chemistry, in anomalies, in silence. The rocks do not speak, but they invite us to listen differently. They invite us to see ourselves not as the beginning, but as a continuation, fragile and temporary, yet part of a pattern older than bones. The penultimate lesson is clear. Intelligence may not be rare. What is rare is permanence. Civilizations rise and fall, but the earth endures. The silence is not emptiness, but the residue of stories erased, and we too will one day be part of that silence. The only question is whether, when we are gone, the earth will light the flame again, in another form, in another lineage, in another time. Perhaps the cycle will continue until the earth itself is gone, consumed by the sun. Perhaps intelligence is not destiny but rhythm. We are one beat among many. At the end of our journey through deep time, one truth emerges with startling clarity. The earth remembers less than we hope and far less than we assume. We seek stories in stone, but the stones are mute. They carry fragments, not full accounts. They preserve shells, bones, isotopes, and anomalies, but they do not preserve the fullness of what once was. The silence between those fragments is vast, and in that silence there is room for countless lost worlds. Perhaps civilizations did rise before us. Perhaps they flourished briefly, altered their environments, dreamed beneath unfamiliar skies, and then vanished. If so, the earth has folded their memories into itself, leaving only hints too faint to decipher. This possibility is not just a question about the past, it is a mirror for the present. We imagine our skyscrapers, satellites, and networks as permanent, but in truth, they are fragile against the scale of geology. If humanity vanished tomorrow, our artifacts would dissolve, erode, corrode, and collapse. Within millennia, forests would reclaim our cities, seas would swallow our coasts, mountains would rise and fall. Within millions of years, almost nothing would remain but chemical anomalies. A line of carbon, a scattering of isotopes, perhaps a thin layer of plastic polymers. To whatever comes after, we might look like a mystery, debated but never proven, much as we now debate the possibility of civilizations erased long ago. The silence of the earth is humbling, but it is also liberating. It tells us that intelligence is not a singular miracle, not the crown of evolution, not the inevitable destiny of life. It is an experiment, one that Earth has likely run before and will likely run again. Each experiment is fragile, each spark temporary, each flame easily extinguished by catastrophe, collapse, or the indifference of time. Yet each spark also matters, because it is the way the universe becomes aware of itself. For a brief moment, through us, through our questions, through our wonder, the Earth is conscious. Perhaps that has happened before. Perhaps it will happen again. We cannot know. The absence of evidence is not evidence of absence. The silence of deep time is not a denial, but an invitation to imagine, to wonder, to accept that we are not necessarily the first, and we are certainly not the last. Our task is not to prove the unprovable, but to recognize our fragility and choose how we will spend the brief moment of awareness we have been given. The myths of lost worlds, the whispers of Atlantis, the cycles of creation and destruction told in cultures across the globe, all echo the same truth. Civilizations vanish. Some vanish into myth, some into stone, some into complete silence. We may be one more in that long line. Or we may be the first to break the cycle, to endure beyond catastrophe, to learn humility from the silence and build with wisdom instead of hubris. The choice is ours, but the time is short, because the Earth is patient and the eraser of time is always at work. As you stand at the edge of a canyon, staring into stone carved by water over millions of years, or as you look up at the stars scattered across the night sky, remember this: permanence is an illusion. We are a flicker, a spark, a breath in the lungs of deep time. But within that flicker lies meaning. Within that spark lies wonder. And within that breath lies the possibility of leaving behind more than just anomalies, of leaving behind wisdom, stories, and choices that ripple into the future. Perhaps someday, long after we are gone, another intelligence will rise. They will dig into rocks, measure isotopes, puzzle over anomalies, and ask the same questions we ask now. Were we the first? Were we alone? Did others come before us? They may never know the answer, and perhaps that is the beauty of it. The mystery endures, inviting every intelligence in every age to wonder, to imagine, to see itself not as the beginning, but as part of a vast, recurring story. The silence of deep time does not tell us no. It tells us maybe, and in that maybe lies both caution and hope. Caution because we are fragile and temporary. Hope because intelligence may rise again and again in forms we cannot imagine, across ages we cannot comprehend. We are part of that rhythm now, a single verse in the planet's endless song. What matters is not how long the song lasts, but how we choose to sing while it is ours. This is the story of Earth, not just of rocks and fossils, but of silence and possibility, not just of beginnings and endings, but of cycles and echoes, not just of certainty, but of mystery. The past is deeper than we know. The future is more open than we admit. And we, here and now, are standing in the middle, looking both ways, wondering who came before and who might come after.